Let's take a look at systems of equations of three equations with three unknowns. Well, in the first example here, I have three equations with three variables, x, y, and z. And the problem is asking me to find the values that satisfy this system of equations, the solution that satisfies each of these equations. Well, let's examine them first. In the first one, I have 2x minus 3y plus z equals negative 3. In the second one, I have again all three variables, x minus y plus z equals 6. In the third one, I only have x plus y equals 12. So I have one of the two equations only contains two variables, while the other two have all three variables. So I can kind of already sense that maybe if I can modify somehow the other two equations, I could create a system of two equations with two variables, x and y. But how do I get rid of the z in either the first or the second equation? Well, together we learn substitution. Can you see between the first and the second equation, is there one that's better to isolate z in any one of them? Well, as a matter of fact, z has coefficient 1 in the first one and has a coefficient of 1 in that second equation. So it doesn't really matter which one you use for substitution. So I'm going to use the first one to show you that it doesn't matter. So z equals, when we're isolating, we have to move 2x and negative 3y on the other side of the equal sign, which means that their signs are going to change as well. So equals negative 2x plus 3y minus 3. And this becomes my substitution value. I'm going to use the z substitution value and use it in the second equation so I can transform it from a three-variable equation into a two-variable equation. So wherever we see z, we are going to use the expression that defines it. So let me just use another color. We have x minus y plus. Now, we said instead of z, we're going to use the substitution value. And that is negative 2x plus 3y minus 3. And everything equals 6. I hope you can notice that we do have some like terms that we can collect once we expand outside of the bracket. So we have x minus y minus 2x plus 3y minus 3 equals 6. Let's collect like terms and simplify our expression. And we have negative x plus 2y. We can move the negative 3 onto the other side and we will get 9. Now I can use my xy equation, so x plus y equals 12. Now I have managed to simplify my system of three equations into a system of two equations. I'm really hoping you can see that elimination is probably the best solution at this time, since x and in the first equation and x in that second equation, they both have coefficient 1, different signs, which means that I can add the two equations and eliminate the x's. So once we add the two equations and we eliminate the two x's, we're going to have 2y plus y equals 9 plus 12. 3y equals 21. We divide both sides by 3. And y equals 7. Well, now that we have y's value, we can find what x is, because we know that we have one of the equations only has x and y variables. So I know that x plus 7 equals 12, which means that x equals 5. And now that we have both x and y, I invite you to substitute them back into z and find out what z is. Well, let's take a look. Negative 2 times 5 is negative 10. So negative 10. 3 times 7 is positive 21 minus 3. Well, 21 minus 10 is 11. Minus 3 gives me that z equals 8. Well, I prepared another example for you, which might be, for some of you, simpler, for some of you more complex. However, it's still, again, a system of 3 equations of 3 variables. Let's inspect this system right now. The first equation is z plus 56 equals 0. I'm really hoping that the alarm bells are going on right now, and you're thinking, wait a second, one of these equations is a one-variable equation. I only have variable z, which means I can actually find out what the value of z is. So z equals negative 56. Well, what does that mean? How is that affecting my 2 other equations? How? Well, instead of z, we can use the value that we got for it and transform the 2 equations into 2 variable equations. So let's see what we get. We have negative 2x plus y minus negative 56 equals negative 10, and negative 9x minus y plus 4 times negative 56 equals negative 37. Well, let's clean up a little bit each one of these equations because once we substituted z, we're going to get more integers, more constants. So we have negative 2x plus y equals, well, the 2 negatives will give us a positive, and positive 56 when moved to the other side becomes negative 56. So we get a positive here, but when we move it to the other side, it becomes a negative 56, which means we're going to get negative 66 onto the other side. And the second equation is negative 9x minus y equals, well, 4 times negative 56 gives me a negative, however, a negative, sorry. However, when we move it to the other side, it becomes a positive. 4 times 56 is 224, so I know I'm going to have a positive 224 onto the other side. 224 and 224 minus 37 equals 187. Positive 187. Again, I'm hoping that by looking at the 2 equations, you notice that the best method to use is elimination. The y's both have the same coefficient, and not only that they have the same coefficient 1, they have opposite signs. One is a positive, one is a negative, which means that in order to eliminate them, to suppress the y's, we have to add the 2 equations. Once we add them, we're going to have negative 2x minus 9x equals negative 66 plus 187, which means negative 11x equals 121, or x equals negative 11. Okay, so now we have x and we have y, we have x and we have z. We do need to find y. Please feel free to substitute x and z in any of equations 2 or 3 and find out what the y value is. I believe for me, I got y equals positive 90. And it would be nice to know if you can check it at home and if you get the same value for y. Good luck.